Okay, hello class. Our topic for today is homogeneous differential equations. So the first order differential equation mxy dx plus nxy dy is equal to 0 is said to be homogeneous of degree n if mrx_ry is equal to rnmxy and nrx_ry is equal to rnnxy. So for m dx plus n dy is equal to 0 to be homogeneous, the functions m and n must be both homogeneous of the same degree. So example, so we have x squared minus 2xy dx plus 4y squared dy is equal to 0. So this is a homogeneous of degree 2 since mrx_ry is equal to r squared x squared minus 2r squared xy is equal to r squared quantity x squared minus 2xy. So therefore, this is equal to r squared mxy. And on the end part of the equation, n rx ry is equal to r squared 4y squared. So this is equal to r squared and xy. So this is, so since they have the same degree of n, r squared and r squared, so this equation is a homogeneous of degree 2. Okay, so for the solution part, let's take another example. So solve the equation x plus y dx minus x dy equals 0. So this is a homogeneous of degree 1 since m rx ry is equal to rx plus ry is equal to r x plus y is equal to rm xy and n rx ry is equal to rx is equal to rn xy. So they have the same degree of n, which is 1. So this is a homogeneous of degree 1. So we have, in a homogeneous differential equation, we have two cases. So the first case, so if n is simpler, use x equals uy dx equals u dy plus y du. If n is simpler, use y equals vx dy equals v dx plus x dv. So from our equation, number 1, n is simpler. N is simpler. So we use y equals vx, dy equals v dx plus x dv. Okay, so since n is simpler, use y equals vx, dy equals v dx plus x dv. Then substitute the values y and dy in our original equation. So x plus vx dx minus x v dx plus x dv equals 0. Okay, so the use of a third variable v or u is to reduce the homogeneous equation into one in which the variables are separable. So after na-substitute tayo ni y and du, we simplify the equation, x dx plus vx dx minus xv dx minus x squared dv equals 0. Cancelling out vx dx and minus xv dx. So we have x dx minus x squared dv is equal to 0. Then after that, we can now do variable separable. So separating the values, x over x squared dx minus dv is equal to 0. Cancel x, cancel x. So this is equal to dx over x minus dv is equal to 0. So after separating the variables, we can now integrate. So integrate. The integral of dx over x is ln x or ln x minus integral of dv is equal to v. Integral of 0 is constant c. So we now have a general solution which is ln x minus v equals c. But we should substitute v. So substituting v. So from the first part of our solution, y equals vx. So v now will be equal to y over x. So substituting v in our equation, so this is ln x minus y over x equals c. Answer. So this is now our answer for number 1.